Conference will now be recorded.
Any doubts from previous sessions? So we are into enhancements, and in our last session we have discussed about exits, and we are talking about baddies.
Exits are nothing but the places which is provided by SAP. When we use exits, when we have a requirement from business saying that without changing the existing SAP functionality, in that cases, we will identify a place where SAP given, and inside the place we will implement our logic so that standard SAP logic and as well as your logic both will work. That is mean by enhancement. A first one, which we discussed as part of enhancements are exits, which may be user exit or customer exit. User exits only provided for SAP SD module, and for all other modules, customer exits are given. And to work with the user or customer exits, we used to have the transaction code SMOD and CMOD. SMOD for exit to identify the exit for a transaction, and CMOD is to implement the logic by creating a project. And later we have baddie. Baddie also a place which SAP was given to implement logic which work with the along with the standard SAP functionality. And baddie we separated from classical ABAP because user exit is subroutine concept, customer exits are function model concept, which is plain ABAP programming language concepts. But baddie is a interface. Interface is object-oriented programming. Hence, we haven't discussed during the enhancement time. We kept aside because to cover object-oriented topic and then come back to discuss about the baddie. Baddie or customer exit, user exit, both are places in my point of view. Place where SAP was given to implement our logic, which will work along with the standard logic. Now, how can we work with the baddie? As you know, already interface. Interface means interface is a template like a class which has methods without any implementations. To use that methods, we need to create a implementation. Now, to work with the baddie, you need to create a implementation. After creating the implementation, whatever methods are there in that baddie, that can be reused. In that way, multiple times the same baddie can be used. Whereas if there is a customer exit and that customer exit is used in one project, a same customer exit cannot be used in another project. There is a limitation. But for baddie, there is no limitation because baddies are interfaces. If you create your own implementation and some other person has a requirement where he wanted to use the same baddie, he can create a different implementation. Multiple implementation means multiple projects can create for a baddie. What are the T codes we use for baddie is SC18 and SC19. SC18 to identify the baddies, SC19 to implement the project. And also we have enhancement framework architecture. When there is a need from the business and we are unable to find a user exit, customer exit, or we are not having any baddie available to fulfill the customer need, then we will go and check with the enhancement framework architecture concepts, which are nothing but implicit enhancements, explicit enhancements. Implicit enhancement is nothing but any T code, we have a one main program. Inside that main program, we can add our logic by identifying the place which is provided by SAP. so that standard logic will work and as well as our logic also will work. How do we identify this implicit enhancements is, first you need to find out the main program and go to that main program, click on viral option so that you will see these dotted lines, which means that is the place SAP has been given for us to implement our logic. You need to right click on the dotted lines and go to edit option menu bar and then search for the enhancement implementation. And then you will be getting enhancement and enhancement. In between, SAP will be asking you to write the logic so that standard logic along with your custom logic will work. And obviously, this implicit enhancements where you can see inside a program with the dotted lines between enhancement and enhancement. You can observe these whenever you see enhancement and enhancement inside any program, that you can say it as a implicit enhancement. Those are implicit enhancements. And as well as what is explicit. Explicit means, again, it will be divided into 2 points. One is enhancement point and enhancement section. What is enhancement point is, let's say there is a program, standard SAP program, and you wanted to explicitly create one place. That means SAP is not giving any place. You wanted to create a place and write logic so that standard logic, your logic will work. In that case, explicitly, we will create a place to write our logic, that is called enhancement point. When you create enhancement point, system will generate enhancement and enhancement. This is called enhancement point. The difference between implicit and explicit is, implicit means place is given by SAP. Inside that place, you are going to write your logic. Explicit means you are creating place. After creating the place, you will be writing the logic. There are two explicit ways you can write your logic. One is enhancement point, another one is enhancement section. If you create an enhancement point to write your logic, then this logic will work along with the standard. But if you create an enhancement section and there is already some logic which is there in the standard and you wanted to not execute that standard logic and you need requirement like your logic should work. In that case, if you kept that logic, standard logic in between enhancement section, that logic will never work. And whatever you have implemented logic, that logic only work. If your need is to run your logic along with the standard logic by creating a place, then you need to go for explicit enhancement point. If your requirement is create a explicit place, create a place in a standard program, that place, whenever you implement logic, that logic only will work. And whatever existing logic, if that logic should not work, in that case, you should go for the enhancement section. And these details we will see in system elaborated way. How we can create a implicit or explicit points and how can we create a logic inside that. What is the difference between the point and section? Those things we will see in system. And everyone are aware of exits. We already practiced with a couple of scenarios. And BADI and enhancement framework we have to discuss. And as I remember, I told to you like this can be discussed after object-oriented programming. So now coming to the BADI. BADI is also a place. BADI, there are two types of BADIs are available. One is classic BADI, another one is new BADI or kernel BADI. What is this classic BADI and new BADI is? Classic BADI, which is nothing but where you can add your logic, that logic will work along with the standard. This is kind of enhancement. You are enhancing the standard SAP functionality by implementing your logic. Whereas new BADI, it's kind of modification, which means you are modifying the existing logic by creating a place inside a standard program. That is what the difference between classic BADI and new BADI or kernel BADI. Whatever you see here, customer add data, which is an example for classic baddie sales order, which is an example for new baddie. We will see in system what is the classic baddie, kernel baddie, where it is the differences. And here it will be written a difference, main difference between classic and new baddie. Classic baddie, straight away you can say it's a enhancement. Whereas kernel baddie or new baddie, you can say it's a modification. And classic baddies will be called outside the program with a statement factory classes. That means CL exit handler get instance. So there is a class called CL exit handler. Inside that we have a static method get instance. By using this CL exit handler get instance, we used to call the classic baddies from outside the program. Whereas new baddies outside the program, we will be calling with the statements called get baddie and call baddie by creating a object reference. This is what the difference between the classic baddie and kernel baddie. If it is a exit baddie or enhancement framework, all these things are designed and given for us where any SAP functionality which is not satisfying the customer need and customer wanted to add some functionality which will work with the standard, or sometimes we wanted to suppress the standard logic and to work only our custom logic. There are place names are different. Few places are calling exit, few places are calling baddie, few places are calling enhancement. The place is nothing but where we can add logic. That logic will work along with the standard, and sometimes that logic will suppress the standard functionality and our logic only will work. This is all about the enhancement concept and the topics, whatever it is there inside the system. Now we will go and see a baddie concept. Baddie, one of the enhancement technique, transaction code for this SE18 and SE19. Let me log in into the system. SE18 is the transaction code where we can see baddie definitions, means created baddies. Customer add data is an example for classic baddie. If you open this, it is created by SAP. The baddie customer add data is a baddie which is created by SAP. And inside that, you can see there is a interface. Baddie is a interface. Interface nothing but it is like a class which has methods without any implementation. Implementation means if I double click, there is nothing which is displayed. Method and method will not be created because it's a interface. If I wanted to write a logic like there is a transaction XD01 or XD02, while changing some customer information, like I am changing customer country here. Now I found there is a requirement from business. Whenever we are changing customer country, we need to throw a message to the user saying that country change is not possible. For that, what we will see, first we will identify a place to implement the logic. That place, maybe if you find customer add data, baddie, this is the baddie which is available. And in save data method, where you are getting the country details so that you can use this save data method. Now, first of all, how do you know which is the baddie which will help us for our requirements? Now, here the requirement is whenever you are changing the country, you need to identify the baddie. So, whenever you got any requirement, first of all, what you need to do is for any T code, normally you will get requirements for a T code. What you need to do, first you need to find out the baddie. To find out the baddie, you need to go to transaction SC93 and enter the T code for which you wanted to find out the baddie. I wanted to find out the baddie for XD02, customer change. Now click on display and then get the package. Once you have the package, go to transaction SC18 and select baddie and click on information system. Now provide the package here and click on continue. Now you can see the baddies which are created and given by SAP to us. Means these are the places SAP given for us. Now you can see customer add data is one baddie is there. If I go to this customer add data in display, I can see there are methods. Save data, check all data, like different methods are there. If I go to save data and I have a customer number as a method input parameter, these are the parameters importing input. So I'll be getting customer number as a input for save data, and this check data changed. This see what are all the inputs which you are coming. Check all data. This is a method, and in this method, these are all the parameters. KNA1, KNB1, KNAS. So like this, you will be having different parameters. In these parameters, which parameter, like importing parameter, is carrying your country information. If you go to KNA1, importing parameter is referring this KNA1. If I go to here, country, so you can see here, country key is there. Land one is the country key, which means whenever user trying to change a customer country, this baddie will trigger, and inside this baddie, check all data method will trigger, and check all data method inside you have the country which is coming, so that you can check whether user changed country or not, and then trigger a message by using the check all data method. Now you have identified a place, and you know where the country information is coming. Now what you need to do, you need to use this baddie to implement your logic. To implement logic, you need to use transaction SC19 transaction. Go to SC19 transaction. Now here, if the baddie is new baddie, enter the baddie name. If the baddie is classic baddie, you have to enter the name and then create implementation. Create implementation is nothing but you are going to create a class for this baddie, because baddie is a interface. Interface cannot be implemented. So you need to create a class for this. Inside the class, you will use this method. Inside the method, you will write logic, so that whenever XD02 is triggered, your place will come, and inside the place, whatever the method you written logic, that logic will trigger and the functionality will work. So this is for customer. If you got a requirement, like I wanted to, if there is a outbound delivery, transaction code is VL02. There is a user, he is trying to change quantities inside the outbound delivery. There is a delivery quantity is there. If any user is trying to change the quantity, I need to stop user. Okay, quantity change is not possible. If that is the case, first of all, I should have this value coming into a place. I need to identify the place for this transaction. And inside that place, I need the value, delivery quantity. Like previously, what is the quantity, and now what is the quantity, so that I can see there is a change. And then I'll trigger a message. Now the question is, how do you know which place is you are getting this delivered quantity? For that, first of all, you need to identify the baddies. Baddie means places. How can you identify the places? Same behavior, SC93 and enter your T code, click on display. Now get the package. And once you have the package, go to SC18 transaction, select baddie and click on F4, information system, provide the package and click on continue. Now you will be having delivery related baddies. So in these baddies, you need to identify what is the baddie which is getting the quantity information. Then in that baddie, you need to implement your logic. This is where more time consuming will happen in real time project because you have a different baddies. You need to go individual baddie, click on display and then check. This is a kernel baddie. You can see this is a kernel baddie. This is not a classic baddie because new baddies under enhancement spot. This is a kernel baddie. This is not classic baddie. Now inside this we have technical details. This is our interface. Inside this interface you have methods and which method you are getting that quantity information. Each and every method parameters will be there. You need to go to the parameter. This is the importing parameter and importing parameter you need to check the field quantity related. If the quantity related field is the target quantity GMENG, then you can use this baddie and implement your class implement baddie implementation. You need to go and implement and then write your logic inside this method so that what will happen during the change, your baddie will trigger and inside the baddie, whatever the logic you have written that will trigger and it will stop user to not proceed further. Now, you need to remember is whenever any requirement comes, the way of finding the baddie and way of finding the place, that is what the most crucial part. Implementing logic is simple. Only thing is identifying the baddie is the most important thing and the baddie identification will be happen in many ways. Right now, I shown you with the SC93 transaction. By using SC93, enter the T code for which T code you wanted to find the baddie and then get the package. Once you have the package, go to SC18 transaction and get all the baddies created for that package. This is one way. And another way is by using class CL exit handler. There is a class called CL exit handler. Inside this, we have a method get instance. So place a breakpoint in this class method and then run your T code for which you wanted to identify the baddie and whatever the exit names coming under this CL exit handler, note down that baddies manually. That is one more way. I'll show you that. And another way is through SC84 T code. If you go to SC84, there we have all applications. Inside the applications, if your application is related to sales or related to delivery, choose your application and for that application, whatever baddies are there, get those baddies. This is one more way. And another way is run a transaction code ST05. It's a trace related transaction. And then use your T code for which T code you wanted to identify the baddie, which means run trace for your T code. And then evaluate the trace and identify the baddies. This is one more way where you can find the places. Identifying the place and also next action is in that place, the inputs are coming or not based on your requirement. If the inputs are coming and the place is available, then you can go and implement logic. If I go to transaction second one, CL exit handler. If you go to this class, there is a method called get instance. Inside this, CL exit handler, get class by interface. So place a breakpoint here. And you can see exit name. Exit name is nothing but your baddie name. Now I wanted to see baddies during sales order creation time. Now execute VA01. When I execute VA01, you can see this CL exit handler which triggered. And this is one baddie, ERP CFG ADPT. Note down this baddie. And F8. This is baddie SD sales. One more baddie. Baddie SD sales basic. Baddie layer. So these are all the baddies which are coming before entering into the transaction. If my need is whenever I was coming into the transaction, I need to pass some default values to order type. In that case, I have to check the places. Right now, 4 baddies are triggered, right? I need to verify is those places are getting the order type information or not. If order type is coming, then I can use that baddies to pass information into the order type section. Like this, we need to identify the baddie and then implement the logic in SE19 transaction. That is what the process way to work with the baddie. Even we can create a custom baddies also. So right now, whatever we see, these are standard SAP provided baddies. And even sometimes we got a need where we have to create our custom baddies. And in that way, also we can create our custom baddies. We can work with the standard baddies. We can also work with the custom baddies. Now, if I create any custom baddie, then how this baddie will be called and how can we implement logic inside the custom baddie, that things we will see now. Let me create a custom baddie. Custom baddie will be created from transaction SC18. Choose the enhancements part. First, I need to create an enhancement part. I'm going to create a classic kernel baddie, new baddie. Choose the enhancements part. First, specify enhancement. You need to create the enhancement part first. Enhancement spot. Create an enhancement part and click on create. This is enhancement spot for custom baddie creation. And click on continue. Let me delete this CL exit handler. Remove breakpoint. I am removing the breakpoint from CL exit handler. Now go back. Delete all breakpoints. Execute. Close this. I'll rerun again. Let me come out. Again, log in into the system. So go to transaction SC18. To create the baddie, first you need to create the enhancements part. Click on create. Baddie. Enhancements part for baddie creation. Click on continue. Save as local object. save it, check, activate. Once you create the enhancements part, now go and create the baddie. How to create the baddie? Here we have a create option. Click on create and specify a baddie name, G baddie, and Sanjay underscore tester. This is my baddie, baddie 1 creation. I am creating a baddie. Click on continue, save. Now baddie is created, but we haven't created interface. So interface is mandatory for any baddie. If I go for save check, I'll get a error saying that interface is missing. Now double click on interface, and here we have to specify the I'll be copying that. ZFIIF means it's the interface. And now save. Interface not exist. Click on create as, save as local object. And it is asking to save the enhancements part. Yes. Now here I need to create a new method for a interface. Interface methods we need to create. So I am going to create a method display message. This is my method, and level is instance, and this is to display text information. Save, check, activate. Come back. So far what we have created, we created enhancements part and we created a baddie. Baddie must have interface. Without interface, we cannot create any baddie. And this baddie is having interface. This is the interface. And interface have a method. Display message. This is my method inside my interface. Now save, check, activate your enhancements part, which is having one baddie. Now baddie is created, and now I wanted to implement this baddie, which means this is my baddie, G baddie Sanjay test. If you go to SC18, select the baddie and enter. This is my baddie, which is just created under a enhancements part. Like baddie sales order, if you open this baddie sales order, which is created by SAP under a enhancements part. And I have created my custom baddie under a enhancements part. So you can parallelly check. This is standard one, SAP created baddie. And this baddie having an interface. If SRA, this sales order is the interface. And I have also created enhancements part. Inside the enhancements part, I have created a baddie, and this baddie is having interface. Basically, interface is having methods. If you double click, these are the methods SAP created. And if I click on this, these are the methods I have created. Now, just baddie is created, but now I need to implement this baddie. Implement means there is a need, there is a T code which is calling this baddie. Now I just observed that this is my baddie, this baddie is calling from a external program. And now I wanted to implement logic inside this baddie. To implement, you need to go to enhancements part, click on display, and then get into change mode and drag this. Now select your baddie and click on implementation. Now here enter your implementation name. So you need to create your implementation. Jet Sanjay and baddie IMPL. This is implementation, and short text is to implement logic inside baddie and click on continue, save as local object. Now you have just created a baddie implementation and enter that implementation details g baddie impl underscore Sanjay. Description is test baddie and implementation class. Whatever the class you created, right, that you can specify here. ZCL baddie impl Sanjay. Click on continue. Save as local object. Now save, check, activate. This is a warning message. Now you can see this is your baddie and this baddie is having an interface. This is your interface and inside the interface you have your method. And this baddie has a implementation also. If you double click on implementation, this is what the implementation. And this is your implementation class name. Inside this class, you have this method. Method is coming from the interface. And if you wanted to write logic, you can double click on this interface, click on yes, and go in change mode. Write some logic. Baddie 1 implementation called. Save, pretty print, check, activate. Now come back. Save, check, activate your implementation. Now implementation also completed. Now I need to call this baddie from outside my program. Outside from program. How can I call this baddie? You need to create a program. Go to SC38. Create a program. G Sanjay baddie. Execution. Click on create. Program to call baddie. And type is executable program. Click on save. Save as local object. Now, how do we call an external baddie, new baddie from external program? You need to create a baddie definition. After that, create object reference and then use get and call baddie so that baddie will be called. So create object reference data obj type ref to your baddie definition. What is your baddie definition? This is your baddie definition. If you go here, you can see, double click on this. This is baddie implementation and this is what the baddie definition. You need to call this baddie definition. And then use get to baddie through object reference. And then you need to use call baddie. By using this call baddie object reference, you can call methods inside the interface. What is the method? Display message. So pretty print, save, check, activate. Now execute. Baddie 1 implementation is called. This baddie 1 implementation is there inside this display method. Inside the display method, we have written our logic. So whatever logic is written inside the display method under implementation of first one, we have implementation side. Inside that we have implemented our logic. That logic which is triggered. So this is our implementation class. Where is our implementation class? So this is our implementation class. Inside this class, we have the logic. Baddie1 implementation was called. So what we have done, we created our program. From program, we have created a Baddie reference, Baddie definition, type ref2 followed by Baddie definition, and then get Baddie, call Baddie will call a Baddie related methods by object reference. Now, if I create one more implementation in the enhancement spot, this is my enhancement spot, right? Now, if I create one more implementation, so I can create n number of implementation, n number of baddies inside this enhancement spot. Now, this is one implementation, enhancement implementation. One implementation is there. I'll create one more implementation for the baddie. So this is my baddie. One implementation is there. I will create one more implementation. One more implementation means one more requirement where other user is getting. So he found this is the baddie which is suitable for his need. Then he wanted to create one more project. To create one more project, that is mean by implementation. To create the implementation, you need to choose that baddie, click on this symbol implementation. Now click on create. Now create a new implementation. G Sanjay baddie implementation 2, and this is test. Click on continue. Save as local object. Now this is one implementation. This is second implementation. Now I am going to implement the second one. Click on continue. You need to specify baddie implementation details. Sanjay 1, and this is test baddie implementation 2. And here I need to provide implementation class Sanjay 1. Click on continue. Save as local object. Now save, check, activate, continue. Now under the enhancements part, you have one baddie, and this baddie now it has 2 implementations. Now technical details, enhancement implementations. Go back. This is enhancements part, and this is the enhancement baddie name. If we go to enhancement implementation, there are 2 implementation, which means this is one user for his project need, he implemented logic here, and another user also need the same place, and he created one more implementation under the same baddie. Now 2 implementations are there. A second user, he is going to write his logic inside the implementation class. Now double click, yes, go to change mode. Now he is going to write his logic, baddie implementation 2 called. This is second implementation. Check, activate. Now go back, activate your enhancement implementation and activate your enhancements spot. Once after that, if you call this baddie, now inside this baddie, two implementations are there. If you execute, you will get baddie one implementation is called, baddie second implementation is also called, which means the logic which are implemented under the two implementation, both are gets triggered. This is a disadvantage inside the baddie. One advantage is you can create multiple implementations for a single place, but all the place related logics will be getting triggered when you call from external source. I believe you have a total confusion about this. Let me clarify you. See, you have a transaction VA02. Okay. I am unable to show this in the screen because since this is a training server, so many people are unnecessarily created different enhancements and it is not allowing to proceed with the standard application. That's what is the major problem. Now I'm giving you an overview, an idea, so that you can correlate right now what we have done. There is a T code. Okay. So requirement is business is saying, okay, whenever a user is trying to change a sales order, let's say sales order number is 80003. There is a user, okay, he was trying to change the quantity. Quantity, we have quantity for every line item. If you open any sales order, we have an item and we have a item related material number and we have material number and this material number has a quantity. If you go to any sales order, you will see the details. Now business needed, if anybody was changing the quantity, we need to stop him not to change the quantity. If to achieve this is a standard behavior. Standard behavior, it will accept by changing the quantity, it will not stop any user. It will accept, they can go proceed and change the quantity. Standard behavior will not stop them. The address number, I don't know. So this is a sales order which is there in the system. If I am trying to change the quantity from 10 to 4, save it. Normally, standard SAP will not restrict me. It will accept and change the quantity. Now, business is saying we should not allow them to change the quantity. Then, to implement the logic, you need a place. Inside VA01, VA02 process, during the sales order change process, you need to find out a place where in this place you are going to capture the quantity and check whether the quantity was user changed or not, and then write a message to stop it. This place maybe you will be find through a exit, or exit means it may be user exit or customer exit, or you may be finding a baddie, or it may be an enhancement architecture, anything implicit or explicit. Let's say you find a baddie for VA02, and inside the baddie name is check all data. This is the baddie, which is SAP given. Inside this check all data, there is a method. What is that method? Quantity validate. Okay, this is the method inside this baddie. So this is the baddie, and this is the method inside the baddie. Now, baddie directly inside the baddie, if you open, there is a interface, IF check all data. Actually, this interface is having the method, but it is not have any implementation. Implementation means it just created. Nothing has been written inside this. Now, your requirement to satisfied, you need a place and you find out there is a baddie. Inside the baddie, you have seen quantity information is coming. In the method quantity validate, for the method, we have import, right? So import is input. Input is quantity is coming inside this method. Now, okay, now this method is getting the quantity during the sales order change process. And if you are getting the quantity, then what you will do, you will check, right? If quantity changed, and if you will write a message, okay, quantity change is not allowed. This quantity changed, how you will check? Inside the method, you will be having import parameter as two ways, like what is that? X quantity, Y quantity. X quantity which is carrying the new value and Y quantity which is carrying the old value. Now, by looking at X and Y import parameters, you can decide, okay, quantity change is there. Then you will write a message so that a system will stop user to not to proceed. For him, it will trigger a message saying that quantity change not allowed. This is the message they can see, and system will stop the user to not to change the quantity. Again, when he click on cancel, again the order will be having only 10 quantity. In this way, you can restrict by implementing. Now, to write this logic, what you have to do, you need to create a implementation for this method. Method means interface. For interface, if you wanted to use the method and write the logic, you need to create a class for this interface. You need to create a class. This class, let's say GCL underscore quantity checker. And this class, which is having interface as the reference, because you are creating class for the baddie. Now this class is using the reference of the interface. Now inside this class, by using the reference of the interface, if check all data, tilt, this we have discussed in our interface topic, quantity validate. Now, if you double click, you will be getting method and method, method and method. So inside this, you are going to write a logic like this. If quantity is something, you are going to stop the user by specifying your validation. Inside this, you will write. So this is called baddie definition, which is just created. Okay, this is not implementation. This is baddie definition. You observed there is a baddie, and inside that there is a method. Inside the method, you are getting the quantity, so that this is helpful. But to use this baddie, you need to create the implementation. Implementation is nothing but creating the class for that baddie. Once you create the class, whatever the methods are there inside the interface, in that methods you can write your logic. So your logic will trigger. Now we created a class, we created a baddie. We created a baddie. Inside this, we have two different implementations. This is one implementation and this is another implementation. Implementation is nothing but implementing your logic. Let's say in the same transaction, one more requirement come. What they are saying business, quantity change is not allowed, but for a certain material. If the material is M-01 and user is trying to change, means we have to stop not to proceed further. This is one more requirement. Then what ABAPer will do, he'll go and see, and again he will find the same baddie. Quantity is coming here and also material also coming inside this. Then what he will do, he will create one more implementation for his logic. So he'll create one more implementation. This is implementation one, which is created by a different user for his requirement. And the same implementation, same baddie will be used by another user and another implementation he will create. This is one more implementation. His requirement is to validate the quantity by looking at the material and quantity change. Now what will happen? The advantage is here, if place is only one place, but it is being used for different logics in two different places. So now the method is same. Quantity change is the only method. Quantity validate is the only method. This method is used in two different instances. Two different logics was built. That is the advantage of baddie. But the disadvantage is when you call this method from outside the program, all the implementations, whatever it is implemented under that, which will be getting triggered. This is what the disadvantage. To overcome this disadvantage, we have a filter option inside a baddie that we will discuss tomorrow. So far what we discussed, we have started understanding baddie concept, and inside this baddie we have two different baddies. One is classical baddie and another one is new baddie. We have seen how a classical baddie and how a new baddie with a standard SAP created ones, and then we have started creating the custom baddie, our own baddie. Inside this baddie we have created two different implementation. Each implementation has its own logic, and the baddie what we have created, that baddie we were calling from outside the program by using get baddie and call baddie. What we observed is we can create multiple implementation for a single place, but the disadvantage is all the implementation logics will work whenever you call the baddie from outside. That is what the disadvantage. To overcome this, we have a filter option. That filter option we will discuss tomorrow. And we will continue with the rest of the topic in enhancement. Any doubts so far today?
If no questions, we can wind up for the day.